Okay, the second theorem that we're going to talk about is the mean value theorem, and there is a reason that it is called the mean value that we'll talk about here in just a second. This is a really incredible theorem that basically says this, so I'll put it into sort of a physical application for you. What the theorem says is pretty much this. Let's say that you went 150 miles in 2 hours. Okay, well what that means is that you basically averaged 75 miles per hour. What the mean value theorem says is that if you average 75 miles per hour over a trip, that at some point, at some time on your trip, you had to be going exactly 75 miles per hour, at least once. And that's what the mean value theorem is basically saying. So I want to kind of point out a couple of things in this theorem. It says that f is continuous on the closed interval from a to b. It is differentiable on the open interval from a to b. So those are the two things required in order for the mean value theorem to apply. And in that case, there exists a number c in the interval from a to b such that f prime of c, well, we've seen this symbol before. F prime of c is what is called the derivative. And in this case, we want to think about it as being the instantaneous rate of change. Okay, so f prime of c is your instantaneous rate of change. This is the rate of change in a function at an instant, at a particular moment, and that moment is called c. And that is equal to f of b minus f of a over b minus a. This fraction right here is called the average rate of change. So I'm going to write that down. It is the average rate of change. And so what this theorem is saying is that if the function is continuous on the closed interval and differentiable on the open interval, then there had to be at least one point where the instantaneous rate of change, or the derivative, is equal to the average rate of change, f of b minus f of a over b minus a. Okay, so let's now use this theorem to see if we can answer some questions. Okay, so we have example 3 here. Hot water is dripping through a coffee maker. The amount of coffee in the cup at time t is given by a differentiable function, c. And remember, we said just a second ago on the other page that if a function is differentiable, that means that it is also continuous. So I'm going to write that down by annotating that word differentiable. Okay, selected values of c of t measured in ounces are given in the table above. Is there a time t? Okay, again, so there is that phrase that we talked about before. Is there a time t? Anytime you hear that, you need to think either IVT or MVT. Is there a time t on this interval from 2 to 4 at which c prime of t is equal to 2? Well, notice that in this problem, I'm given c of t, not c prime of t. So anytime the question is asking you to prove something about the derivative, that's when you need to think MVT. Okay, so that's kind of what makes these questions a tad bit difficult in calculus, is that you have all of these theorems at your disposal, but you've got to figure out which one you're supposed to use. Since we are given c of t and asked to prove something about c prime of t, that's how we know we're going to use the mean value theorem. Well, so what does the mean value theorem say? It says that the function has to be continuous and differentiable, and that's certainly true in this case since the problem told us that, and that if those things are true, that the derivative, which in this case is denoted by c prime of t, is going to equal the average rate of change over the given interval. Okay, so the given interval is right here from 2 to 4. What I want to do first is I want to calculate the average rate of change over that interval. So the average rate of change, sorry about that, I messed up a little bit, I'm going to rewrite that, is going to be c of 4 minus c of 2 divided by 4 minus 2. And the place that I'm going to find the c of 4 and the c of 2 values is from the table. So c of 2 is going to be right here. C of 4 is going to be right there. So c of 4 is going to be 12.8. And c of 2 is going to be 8.8. And I'm going to divide that by 2. And And 12.8 minus 8.8 is 4 divided by 2, which is equal to 2. And so since the average rate of change was equal to 2, and this function is continuous and differentiable, I know that the instantaneous rate of change, which is given by the derivative, this guy right here, has to also equal to 2 for some time t in the interval from 2 to 4. So everything that I basically just said out loud to you, I'm now going to write on the paper. So I'm going to say, since this function, c of t, is continuous and also differentiable, there exists time t, or you could just say t if you wanted to, for t less than or equal to t less than or equal to 4, such that, and then I'm basically just going to redo the calculation that I just did. C prime of t is equal to c of 4 minus c of 2 over 4 minus 2, which we already calculated was equal to 2. Okay, so this is how I'm going to justify my answer. When you guys work problems on the assignment, you need to try to model this as best you can. And if you have questions, then please feel free to let me know. Okay, example 4, let f be the function given by f of x is equal to x cubed plus 5x. This question is asking what value of c is guaranteed by the mean value theorem. Okay, well I know that the mean value theorem says that f prime of c is equal to f of b minus f of a over b minus a. Well, the question is, what are a and b? Well, remember, those are the numbers that are the interval that you're talking about. So the interval that we're talking about here is 1 and 3. So my 1 is going to be a, and my 3 is going to be b. So the first thing I'm going to calculate is, what is the average rate of change? Okay, well, the average rate of change is going to be f of 3 minus f of 1 divided by 3 minus 1. So the question is, how do I find f of 3 and f of 1? Well, the function is given to me right here. So I just need to substitute in 3 and 1 into the function so that I can get the value. Okay, well, if I substitute in 3, I'm going to have 3 cubed, which is 27, plus 5 times 3, which is 15, and 27 plus 15 is 42. Minus f of 1, 1 cubed is 1, plus 5 times 1 is 5, and 1 plus 5 is 6. Divided by 3 minus 1. If I do the arithmetic there, I'm going to get 36 divided by 2, which I know is 18. So that is the average rate of change, 18. The next thing I need to find is the derivative, because I know that the derivative is going to equal to the average rate of change. So f prime of x is going to be 3x squared plus 5. Okay, so there is my derivative. Okay, so now I'm going to use the conclusion of the mean value theorem, which I put right over here, in order to find out what c is. So f prime of c is going to be 3c squared plus 5, and that's going to equal to the average rate of change, which was 18. Okay, if I now use algebra to solve this equation, I'm going to subtract 5 on both sides. That's going to give me 3c squared is equal to 13. And then divide by 3 on both sides to get c squared is equal to 13 divided by 3. And then the last thing I need to do is take the square root of both sides. Now, a lot of you are going to tell me, and correctly tell me, that whenever I take the square root, I need plus or minus the square root of 13 over 3. But in this case, we're only going to take the positive square root of 13 over 3, because if you look back at the interval that was given to us, negative square root of 13 over 3 is not on that interval, and so that is not necessarily guaranteed by the mean value theorem. So my final answer is just going to be c is equal to the square root of 13 over 3. Okay, so hopefully that makes sense to you. There is a problem very similar to that on your assignment, so please let me know if you need help or have any questions.